Here's the data table from my crater inquiry. My question was, how does the diameter of the asteroid affect the radius of the crater? All of our data tables always have the x-axis first and then the y-axis second. In this case, that means that diameter is the independent variable. And that's right, that's what I changed every time I dropped my asteroid. So now I want to plot this. I want to make a scatter plot of it because the goal is to create a trend line if it's linear and to figure out the equation of that. So I need to first figure out what axis each one is going to go on. Now I'm ready to do my scatter plot, and I've created my x and y axis. Again, diameter of the asteroid goes on the x-axis. It is the thing that I changed every time I dropped my Plato asteroid. And on the y-axis, I've got the radius. That's my dependent variable. It's the thing that changed based on the experiment. I have to figure out my scales. Now, I have a bunch of lines on my x-axis, and I'm going to count up how many I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If I keep going, I probably have 21, 22, 23, 24, 25 that I can fit in there. The largest number on my x-axis that I have to plot is 8. So I need to figure out a scale. I need to somehow divide 25 lines with 8 values. I need to be able to fit that in there. So what I'm going to do, I'm going to take my calculator and I'm going to figure out, my biggest number was 8. That's why I have to figure out a diameter of 8. And I want to divide it equally amongst 25 lines on my grid. That gives me 0.32. I don't want to count by 0.32. That's hard to do. I want to count by easy numbers on the scale. I can't go down to 0.25 because then I won't fit it on. I need to go to the next biggest number to count by. Some students might choose 0.4. Again, that's not really that easy of a number to count by. I'm going to choose 0.5. Usually people can read a graph, count by 0.5s. So I'm going to go back to my graph, and I don't want to write out, my writing's not very neat. I don't want to put 0.51, 1.52. I'm going to skip a line. There's my 0.5, and now I'm going to put 1. I'm going to put 1.5 and 2. 2.5 and 3. And we end up having it go to 8. Takes up more than half of that axis. It's going to be nice and spread out. Now it's time to do our y-axis. On the y-axis, I have 6 as my largest value. And I already counted my y-axis. I have over 30 lines that I can go up on. So I'm going to take my largest value I have to plot, which is 6. I'm going to divide it by the 30 lines I have to play with to divide it up into. And I get 0.2. I could count by 0.2s, 0.2, 0.4, 0.6, or I could count by 0.25. That would work as well. I'm going to go by 0.25. Nice, easy number to count by. As long as you use something that's easy for you. So again, I'm going to start here. Here's my 0. I'll add a 0 here for my x-axis. So 0, 0.25, and after 0.25 is 0.5. And after 0.5, 0.75, 1. If counting by 0.25s isn't easy for you, then count by 0.2s or find a number that's easy to count by for you. 1.25, and I've got 1.5, and so on. And end up with my scales all done up to 6.0. And I only put 0.0 there because in my head I was counting by 0.25s, and 0.5 I got 1.0. I could have just written the number 1, 2, 3. I didn't need to put 0.0s on there, but I did. A lot of students would say that their x-axis goes by ones, 1, 2, 3, 4, but it doesn't. To remember that each line represents what our scale is increasing by. So this one is by 0.5, this one is by 0.25. In my class, a lot of times I yell out scale check to make sure we realize it's not going up by ones all the time. We have to make sure we're careful to be reading these scientific mathematic graphs that we're creating. Now my next step is to plot the points. So my first ordered pair, my first xy is 1, 1. And I could write that beside the data table. Sometimes students, we forget that that represents that point on your graph. So I'm going to go on my graph, find 1, 1. So my x value of 1 goes up, and there's my y value of 1. I put a dot. My next point, 3, 2.5. So my x value is 3, and my y value is 2.5. So I go to 3, and I go up to 2.5. There's my 3, 2.5. And I'm going to plot the rest of the points. And I end up with this scatter plot. My next step is to create a trend line for this. So I'm going to take my ruler. I try to use a clear ruler. I'm going to try and find a spot where it goes through as many points as possible and has about the same number on each side. In this case, I've got 3 of my dots below, 3 of them above, and that looks pretty good, and I'm going to draw that trend line. Never do dot to dot, jagged lines or zigzag lines. It's always a trend line to represent the trend of my data. And my trend line looks like that. Now, that was the part that we've already done in our Scooter Games qualification. Now we're at the point where we need to take this one step further. If you take a look, it crosses my y-axis at a certain point. And it's got a positive slope because it's increasing. Its rise goes up and it runs forward. So positive up, positive forward. Now I need to figure out what that rate is, or that slope. Those words we've been using are the same, rate and slope. And I need to figure out the y-intercept for my equation. So I'm going to go back to a sheet of clear paper right here. I'll go back and forth between the graph. I'm going to do my work right here. My guys, we've always said we can always write down the equation to start. So the equation of a straight line of a linear relationship is y equals mx plus b. The m we fill in with the slope or the rate of the graph, and the b we fill in with the point that it crosses the y-axis. The x and the y represent any ordered pair on that line, and I'll show that right at the end what those two letters stand for. We'll get to that later on in another qualification, but for right now, I'm going to show that at the end of this video. So I need to figure out the y-intercept to start, what our b value is. We always write our y-intercept as an ordered pair. And I'm going to go back here. Now the y-intercept, it's that spot right there. That's my y-intercept. And it has a value in the x of 0 and a y value of 0.5. So I'm going to go over here and fill that in as an ordered pair. So anytime you ever ask for the y-intercept, it's 0, 0.5. In terms of my equation, well, I keep my y there. I'm going to keep m there for right now. I haven't figured out the slope yet, but I do know what the b value is. The b value is this number, wherever it crosses the y-axis. And again, it crosses my y-axis right at 0.5. So I'm going to put that in there right there. Now I need to figure out the slope. I'm almost there. So for my slope, there's lots of ways to look at it. There are equations for it. There are different ways to do it. I always like looking just, hey, it's our rise over our run. It's how much it's going up by how much it's going over by. Rise goes up and down. It could go positive, could go negative. I usually look at run always being positive, always going from left to right. So I need to figure out the difference between two data points that are on my line. If we take a look, none of my data points are on there. So I'm going to take any point on that trend line that I can read. Nice and easy. I'm not going to pick this point right here. This point right here, it's a little bit below that. It would be hard to figure out on there. This one's no good. So I'm going to go up and down my line, and I'm going to find a spot. I love that spot right there, because that spot is right on an axis, and its x value is in between 2 and 3, so it's got an x value of 2.5 double check that, yeah. And a y value of 2. I'm going to keep going and find another one right there. Perfect spot. Because again, I'm trying to find the rate of this trend line. Nothing to do with these data points, this line. So I need to use points that are on here. And that point right there has an x value of 6 and a y value of 4. I'm going to transfer these over to my other sheet. So I've got 2 data points. So point 1, actually I'm going to go down here. Point 1 was 2.5, comma 2. And point 2 is 6, comma 4. To figure out the rise, I need to know how much my y changes, how much it goes up by. Some students will go here and they'll say, oh, it goes up by 1, 2, 3, 4, 5, 6, 7, 8. Well, I got to do a scale check. My scale is completely different. Every line on here represents something different. It represents 0.25. So you could figure that out by drawing a little triangle. Sometimes teachers show that method and you count them up. I'm just going to take a look at these numbers though. I know that that point was at 2 and then it was at 4. That's an increase of plus 2. That's my rise. And my run over here goes from 2.5 to 6. If I grab my calculator and I do 6 take away 2.5, or I use mental math, I end up figuring out it's plus 3.5. So I'm going to pop back up here. I know my rise and my run now, because this is my run over here. And I get a rise over run that is 2 over 3.5. And when I calculate that, I can put that as a, 2 divided by 3.5, and I get a slope of 0.57. Go back to my equation. And that's the equation of my graph. What that means is, for every, my y-axis again was radius. If I want to figure out a radius, I take whatever the diameter of my crater was, multiply it by the rate, 0.57, and I add in the starting value. So that right there is the equation of the graph. Sometimes students will say, what do the x and y mean? I mentioned that before. Well, if I want to figure out, let's say, a diameter of 2 centimeters, so an asteroid with a diameter of 2 centimeters. I take my equation, and I'm going to say, well, my actual diameter is 2. And I evaluate that. And I take the calculator, so 0.57, that slope value, times 2. And then we're going to add in 0.5, my y-intercept. And you get a value of 1.67, or 1.64. That data point, 2, 1.64, should be on my line. I'll leave it right there, 2 and 1.64. So when I'm at 2, I go up to my line, I'm right there on my y-axis, and that value right there is right around 1.64. That's what that means in there. Hopefully this has given you some help to figure out your equation for your inquiry. Again, don't hesitate to ask one of your teachers, your engineering teachers, if you have any questions.